event, I reach out to my peers, my teammates, and all my seniors to help me out. And that is the idea behind everything. This tech community is kind of a community, kind of is where we all realize that there's always a beginning, and it is not shameful, and we should not be apprehensive to ask questions and doubts should we get stuck anywhere. So I would expect the same from you as well. Anytime throughout the workshop, should you have any question, anything, any comments, any concerns, you can always reach out to me. Like, you can always unmute yourself and speak up. Okay. The only rule is that A, be respectful to other people in the group. B, be respectful to yourself. And then if something is left, then be respectful to me as well. Okay. So let's keep it professional. And when I say professional, it is important for me to emphasize that while we're keeping it professional, it is also important to have fun. Lots of fun. And should you have any doubt, anything, this is not a college thing. This is like, someone a bit older than you coming back to you and telling things for you from the perspective of the industry. Okay. So are we all good? I hope so. So anytime when I ask a question, I would expect a reply. So if you could type in the chat window like yes, no, something like that, it would be really great. Okay, so I will now stop sharing my video so that we can focus on the things that that we are really concerned with. Okay, so before we actually move on, so I graduated in 2020, a bit of introduction from SRM-IST. And I've been working in the data science and machine learning track at Infosys. Okay, all right, perfect. So let me stop. I don't think that we require the video right now. Turn off the camera, and then second, and then we'll continue. Okay. All right, perfect. So just a second, let me grab my. Okay, all right. So that's a reason that all of you must have come over here, and that reason being that we need to know a bit about the industry. So let's get to the most juicy part at the very beginning. That is peeking into the industry part. So what are the career pathways? So let's start with that. Okay, because we all of us here to learn about this thing, and maybe this will not only reassure your faith in AI and machine learning in general. Maybe people who are just over here to exploring, it may give you a motivation to do to get into AI. So before we actually begin, I want to tell you that AI is very, very broad. Okay, so there are lots of niche that you can specialize even within AI. You could become really good as data engineer, could be data scientist, could be, let's say, or you can actually go into specialized niche as well, like could be natural language processing. For me personally, I like privacy issues in privacy enhancing technologies or privacy issues in AI so that we could solve. And this is a challenging part, and very frankly speaking, the most exciting part to me, at least personally, to me in AI. Your view could be different. Right. So as you can see on your screen right now, every company is offering, almost all company is trying to become an AI company nowadays. And now the problem with AI job title is that it is not mature. When I say mature, it is not mature. If I tell you that what a full stack developer, you will know for a fact that a full stack developer is someone who develops software from front end to the back end, and also knows how to build the APIs and everything. So it's like an overall all-rounder kind of a developer. Okay, so we know for a fact that what a full stack developer does. Why? Because the entire area expertise or area of full stack development is actually mature. It is well defined. But in machine learning, it is not very well defined. As you can see on your screen, for the same job, for the same kind of job, different companies will use different titles. So machine learning engineer is used by one company, while the other company may use machine learning scientist. So there are obviously overlapping skills required for, let's say, a data scientist or a data analyst and a machine learning engineer, but it is very difficult to actually segregate them because all of them are overlapping. Okay, so this record has been taken from Workera, so those credits go to them. So yeah, so it is actually a very hot time to actually jump into data science and machine learning. Now, with that being said, any company who deals with machine learning and AI in general, the fuel is the data. And data is actually extremely sensitive, not only to corporations, but also to individuals. And you don't want to give that kind of data to someone who is fresh out of college or who is inexperienced. And I think for that reason only, companies are a bit apprehensive to give their data or give the role of a data scientist to someone who's inexperienced in terms of either work experience or in terms of, let's say, education. To wit, most of the roles that you will see in this sphere will require at least 4 to 5 or 7 years of experience in the related AI machine learning field, or at least a master's degree. But that trend is changing nowadays. Earlier it was almost 100%, but nowadays we can see like 80 to 90% requires master's degree at least. The rest 10%, you can see that people are actually becoming data scientists, just out of with bachelor's degree. But with that being said, even those 10% of population will have some work experience in a related field. Okay, so I don't want to, I want you to take this as an encouragement that the trend is changing in the industry. With that, you should equip yourself with the necessary skills, and probably you will land a job one day if you have sufficient skills and you can beat the market, or in some sense, beat the other participants who are actually competing against you. If you could do that, you will be able to secure a job. Now, I understand that job is not the only thing. Like, there is no point in doing a job in a company which you don't like. It's like getting into a toxic relationship. So getting into toxic relationship could be like your girlfriend or boyfriend might be extremely attractive, but if the relationship is toxic, there's no point in continuing that. Same thing, if you not only have to go after AI because it is hot nowadays, it could be toxic because you may not be able to understand this thing, you may not be able to keep it up, or maybe your personality is different. Because AI is such a field where you will have to learn a lot, like every single time. And if you're not willing to do that, if you don't have that inherent curiosity, that it may not be for you. Okay? So this curiosity actually comes from within, and frankly, no one can actually push you to do that. And frankly speaking, if someone is pushing you to do that, you will soon enough break. You will soon enough lash out, burst into flames, and you will say that, hey, I don't want to do it anymore. Probably you will change it. Okay. So the reason I said that is because, you know, we should rather focus more on the skills, what is required, right? Rather than looking on to jobs, companies. Right now, we should focus on skills and just explore and have fun. And when I say have fun, have serious fun. Like, if you are serious enough, you will understand that making projects and everything on this thing is actually incredibly fun to do it. So, as you can see on the screen, these are some skills that is required by the following, that is required by these job titles. So, for example, a data scientist should ideally be good in data engineering, modeling, and business analysis. So, one thing that will be common among all data scientists, machine learning engineer, a data analyst, a software engineer focus on machine learning, a machine learning researcher, or even, frankly, a software engineer would be data engineering. That means all of them should have some idea. When I say some idea, a like really good idea, a really good command over how to engineer the data. Now, you might be wondering, what on earth is data engineering? Well, it could be anything from collecting the data to actually cleaning the data and doing some feature engineering and doing some data analysis. So it is actually a mixture of everything. So, before actually going and collecting the data, you have to understand, like, from where is your data coming from? Is the source reliable? If the source is not reliable, then probably your data is corrupted. It is probable. It is possible, and you wouldn't want to do that. So the starting journey of any AI project would be the data engineering part, which includes anything from data collection to I don't know, to understanding even the business problem. It could be that. Now, it is exciting, frankly speaking, you know. And as you can see, now here it is where you may want to like look at. For example, let's say you may not be really good at coding, or you may think that you have insufficient expertise in coding and experience in coding. So that would mean probably you shouldn't be going after the, let's say a machine learning engineer or a software engineer role kind of thing. Let's say you're not excellent in coding, but you are really comfortable and good with mathematic part, okay, the modeling part. Then probably modeling, becoming a data scientist might be in your best interest, or maybe a data analyst, because they don't involve much of coding. Like, of course, data scientists also codes, but it's not development, it's not debugging. Well, debugging is there in different format, but it's not particularly you're developing an infrastructure. You're not coding an infrastructure, an entity out of nothing. You're scripting. You typing the code to extract insights from the data, and that is a different kind of code. Okay, when I say different kind of code, it is like not at all, you're not building an infrastructure. That's all I want to say. Now, people who have been coding, let's say doing competitive programming in your college, or have been making some projects, you will understand that software engineering is fundamentally different in the industry. Okay, the majority of the time of a software engineer in the industry actually goes into debugging. Okay, you're not going to do hash maps or linked list, these kind of things, at least not for a very long time. When I say that, I want to say that you have to understand that what industry requires from a software engineer is actually to build an infrastructure, to build a house. You have to build a house. Okay, so competitive programming is all good, but the idea behind data structures and algorithm is actually to optimize your code. Now, if there is nothing to optimize, you have to create first. So you'll have to do that first, okay? And only then you can optimize it. Now, I understand that optimization also comes into while building the stuff, and that is absolutely fine, and that does happen. But the majority of the reality is, when the code is deployed, when your program is deployed into the real world, a lot of problems start coming up. A lot of edge cases that you may not have taken into consideration while building may come up, and you may have to fix that. And that fixing the part is what software engineer does most of the time. And that requires, like, I truly believe that there is nothing known as an okay-ish engineer or an okay-ish developer. You either have to be good, or if you're not good, by default, you're bad. When I say bad, you will take the company down with you. Okay, if your infrastructure is bad, the company will collapse on itself when faced with real world edge cases. So you have to be good. That is the reason that product-based companies go after good engineers, because they realize that you cannot afford to hire a mediocre engineer, because a mediocre engineer by definition is not good, is not excellent, so they will doom your project. And we can't afford to do that. Okay, so it's kind of binary in software engineering. Now, if you think that coding is not your cup of tea, that is absolutely fine. In AI, we have everything for everyone. So you could become a data analyst, so BA or a business analyst. That is fine. It is close to data engineering, or it is close to kind of data scientist. Okay, so I want you to know, like, you have to introspect. What is it that you are good at? Okay, so spend some time to understand who you are, to understand your personality, to understand your wishes. Okay, it's not only about money. Frankly speaking, after 2 years, 3 years into industry, you will realize that money is not everything. And frankly speaking, like, after 2-3 years, if you are a competent person, if you're a curious, a hungry person, or a thirsty person, you will earn good. There is no stopping to that. You will end up doing that, because you will be working on yourself, and you will be showcasing that to the world, and companies will come after you, or you will do amazing stuff. That is inevitable. So, but what you have to understand is that, are you enjoying the process, or is it soul killing? Is it soul crushing? What is it? So ask that question to yourself, and then prepare. I know, like, it may be too much for you to take in, or to even acknowledge what I'm saying, because you're in college, and that is absolutely fine. but I want you to have a mature perspective of the real world over here. Okay. So moving on, if you were to find that what is the task of what task does a data scientist concern himself or herself with, the tasks are these: modeling, deployment, business analysis, and data engineering. And the skills that a data scientist should be having are these: should be good in data science, mathematics, machine learning, some algorithmic coding, and obviously communication skills should be really good, and business acumen. So I'll tell you why business acumen is extremely important. The reason behind business acumen is, okay, let's take a scenario right now. Let's imagine that you are from bioengineering background, okay? Or in other words, you're from medical background. Now, assuming that you've been studying this bioengineering thing for 2-3 years, and you've been working in industry for a couple of years, I would assume that you, being a reasonable person, are now competent in the said field. In that case, you have an edge. You have a natural acumen for that. Excuse me. I hope the screen is visible, yeah? Okay, perfect. Right, so you will have a natural acumen for that. So when I say natural acumen, it will be an acquired acumen, not exactly natural, but it will be kind of natural to you now, because it will be second nature kind of thing. Okay, everything what you will be looking at will be from the lens of a bioengineering kind of thing. It's just like saying that when an aeronautical engineer looks at a plane, he looks at all the internal stuff. But when I look at a plane, all I see is a long tube with small wheels which can fly. Simple as that. Okay. Now, you would be an excellent candidate to become a data scientist in the healthcare industry, because you know the in and out of the industry. But me, on the other hand, while I could be a really good data scientist, let's say in the tech industry, I may not be really a good candidate to become a good data scientist in the healthcare industry, because I have no idea about the business over there. So even if I use the tools to extract it, first of all, I won't know what kind of insights are we looking for. Like, even if the client tells me these are the insights that I'm looking for, it will be difficult for me to actually, to make a decision, because in data science, in AI, in general, one of the fundamental thing is that after you extract insight from the data, you have to make a decision now. And you can only make a good decision if you know the business inside out. Okay, so that is the idea. So that is why business acumen is extremely important for a data scientist, or anyone for that matter in business. Okay, same goes for data analyst. So as you can see, the data analyst is not really concerned with software engineering kind of part, because well, they don't have to build the pipeline, they don't have to build anything, they just have to do the analysis. They don't have to build per se. But a machine learning engineer will have to build something. So that is what they would require software engineering skills, and obviously algorithmic coding part. Now, the algorithmic coding part is important because you have to optimize your engine. Okay, and you can only optimize your engine if you know, like, if you're up to date with all the state-of-the-art technologies and the concepts in AI in general. Or for example, nowadays you cannot use, or you should not be using RNN or LSTMs to do natural language processing stuff. Like, you can do it, but if you have transformers and if you have sufficient like if the resources are available, I would rather go with transformers. However, you should, like, there are cases where you may want to use LSTMs, because the task at hand is not very huge. Now, you may ask what LSTMs are. Now, LSTMs is just an architecture that is used in natural language processing. Now, for that, at least you would agree with me, like majority of the NLP engineers will agree that RNNs are kind of out of date. They are kind of dead. Frankly speaking, so is LSTM, but still LSTM can be used. Okay. Now, what LSTMs are, that is not really a concern at the moment, because that is out of the scope. So I won't focus much on that. But remember that there is something known as state of the art. Okay, and you would rather use which is useful to you. rather than something, rather than an ancient technology kind of thing. Then comes the machine learning researcher. Now the machine learning researchers, this is one of those positions which companies are looking for, and companies are willing to pay really good money, but you will have to have at least a master's, like preferably a PhD in your niche, okay? Because you have to do research on this thing. You have to, even if you're, let's say, in your company, let's say you are in Samsung labs, R&D labs, research and development labs, or probably in Google research and development labs, you'll be focusing on a very, 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 very specific and niche field within AI. Could be, let's say, privacy. You want to enhance the privacy of the models that are deployed on, let's say, Google services, or probably if you're working at Apple, you want to improve the privacy on your iPhones. And you are working on that. Such kind of things will require obviously a hell lot of mathematic knowledge, because frankly speaking, like if you're doing PhD in AI, you will automatically would have gained those kinds of skills in mathematics and research acumen. You should be knowing how to conduct a research and everything, like what the methodology used here and there. So this is like extremely academic in nature, okay? But and these kind of skills, like if you want to become machine learning researcher, it usually takes about like easily about 7 to 10 years, because a PhD, like first you'll have to do, like right now you're doing bachelor's to complete, then you will go to do masters for at least 2 years. And then a PhD takes about 5 to 7 years to complete. So by the time you become machine learning researcher, you will be around 29, 30, 31 years old. And so again, you shouldn't go to machine learning researcher path, because it pays you really well. Frankly speaking, a lot of them doesn't really pay you well. Only selected companies pay you really well. And the primary objective should be to do research. You should be hungry to do research in your interested in your preferred field. Now, similarly goes for software engineer, machine learning, focused on machine learning. Could be like here, this person might be building the architecture and the infrastructure to let's say to build a pipeline or the entire infrastructure around which the AI engine would work. Okay, and same goes for the software engineer as well. Now, the important thing that you have to be, that you have to remember is that you have to be patient with yourself. You have to know that this field is such a field that where failures is almost second nature. Like you should be looking for failures, frankly speaking, because the only constant that in AI and machine learning is going to be failures and setbacks. And when I say setbacks, like your model may not work. And the beautiful thing about machine learning is that, rather than software engineering, is that whatever work you do, the results will be live, or you could get the feedback of your work in a few weeks. But in traditional software engineering, you may have to wait for a few months at least to get the feedback from the customers. The beauty about machine learning engineering is that you will get the feedback almost immediately, relatively speaking. So what is that you should know as people who are in college? You have to be relentless, because you know for a fact that this is in demand, and this is not going to go out of fashion or out of demand, at least for the next few years. So I guess that is just a, this is the kind of thing that I wanted to say, at the very beginning of this presentation. And during this workshop, I will demonstrate to you two or three very small examples of linear regression, and classification in machine learning. Okay, so let me stop right here and ask you any questions, any concerns, any queries. So I'm opening the stage to everyone. Is there anything that you may want to ask me, or you may want, anything that you can, anything, like it could be opinion also. Okay, I guess we're all good, yeah? Oh, okay, so we have people from biotech as well. Okay, yeah, great to have you, Rajiv. So I'm really glad you're from here. So people, like, can I get an idea, like, which background are you from? From, like, you can type your major over here. So Rajiv says he's from biotech. I reckon most of you would be from CS or IT background. Is there anyone who's not from CSE IT background? Oh, we have people from mechanical as well. Very well, good. Chemical, wow. Electrical, CSE, we have CSE, mechanical. Okay, really good. So we have a bunch of people. Okay, that's really good. See, as you can see that I have seen people coming even from civil engineering background into data science. Okay. So nothing like these things are not very important. Like these, well, there are these things, but you have to find the industry that you want to go in because every industry requires a data scientist nowadays. Every industry. So if you want to become, so if you're from mechanical engineering, I'm not an expert in mechanical engineering, but I believe that you might be a good candidate to break into, let's say, automotive industry. Could be, yeah. I could be wrong though, but I'm not an expert. So what I can say is that you could be. So because every industry deals with a lot of data. I mean, imagine that you are a data scientist in Tesla. It's possible, yeah. So a mechanical background or an automobile background could come handy over there. Same goes for like if you want to go into IoT, Internet of Things, ECE. Well, frankly speaking, ECE, electrical and electronics and communication, and computer science are strikingly similar. It's very very similar, like kind of brother, brother sister, you know, this thing only, the majors only. Okay, all right, sounds good to me. So for these 2 days, I was planning to actually walk you through code, and I will be using Jupyter Notebook. So so people who are from non-tech background, I want to tell you that the this is the Jupyter notebook that I'll be using. So hang on, so let me create a new notebook. So you may ask me, what on earth is a Jupyter notebook? Well, Jupyter notebook is an IDE, a special IDE which is kind of a notebook where we have individual cells, and I will be using Python language. Now, okay, so also one more thing, that which language should we choose? I would recommend go with a language which is easy for you to pick up, B, which is popular. When I say popular, the reason being, if you encounter any problem, the chances are someone else might also have encountered the same problem, and they will actually help you out. Best example, Stack Overflow. Okay, and however, don't limit yourself to only one programming language. Python is a good language, but like try to get accustomed with a static language such as C++ or Java as well. Okay, could be anything. Like don't limit yourself, or could be JavaScript as well. Now, this is where we'll be typing the code. So we could type anything. We don't really care. So I will use this thing. So before actually we move forward, let me tell you what are we going to learn in these 2 days. So I'll be focusing on machine learning part over here. Where is it? Yeah. Okay. All right. So tell me, how many of you have actually watched the movie The Imitation Game? I'm curious. Has any of you watched the movie Imitation Game? Pranjan, I guess, has raised his hand. Is there anything you want to say, Pranjan? Oh, okay. You've seen the movie. Okay, could be that. Okay, perfect. So, people, if you've not watched the movie The Imitation Game, I would recommend you to go and watch it. It's an excellent movie. Benedict Cumberbatch has played the role of Alan Turing, and you cannot go wrong with him at all. Like, he's an excellent artist. And over here, as you can see, in 1950, Alan Turing was a British mathematician and a code breaker. So in 1950, Alan Turing, released a paper. The paper was named on computing machinery and intelligence. And as you can see in this paper, the first section was the imitation game. And the movie is also named after this section only, the imitation game. So Turing proposed to consider the question, can machines think? And in this paper, first of all, this paper is extremely good read. You don't have to be technically knowledgeable to understand this thing. This is kind of a 11-page article, and anyone can understand this thing. So Turing gives several arguments as to present the idea, or to propose why can we propose that machines can think. And I do agree with him. So to propose that thing, to he gave us a thought experiment. The thought experiment is actually known as the imitation game. So it's kind of a game where you will be the evaluator over here, okay, and then there are two people, there are two entities on that are kept in two separate rooms. In one room there will be a computer, and in the other room there will be a human being, okay, and you don't know as an evaluator in which room is what. And your job, the only job is that of you is to determine in which room is what. So you have to correctly tell in which room is the human and in which room is the computer. Now to do that, you will ask a series of questions on a pre-selected, predetermined topic to both of the entities, and the both of the entities will reply to you in such a format that you cannot infer from their reply that they are human beings or not. For that means that means the human or the computer are not allowed to use audio, because in audio you will be able to infer, like, is this a machine speaking or is this a human being speaking. No handwriting, nothing. So preferably in a type format. Now if it is a type format, I guess it is like you cannot distinguish if the person who's written is actually a human being or a computer. Okay, so the reply would be in the type format, and you will ask a series of questions on a predetermined topic to both of them. And at the end of this, at the end, after once you've received the replies, if you are unable to determine in which room is what, the computer would have been said to imitate the human being into fooling you to believe, to think that the computer is actually human being. Okay, so in other words, computer has successfully imitated the human being, or in other words, the computer would have been said to possess artificial intelligence, kind of. So this is the idea behind this thought experiment. Okay. Now the beauty of of Turing was, okay. So I would recommend you to watch the movie. It's an incredibly good movie. I won't give you any spoilers, um, but you will fall in love with Alan Turing after this. Extremely humble person, and unfortunately, what happened to him should not have happened to him at the end. Okay. Anyway, so in the today we are going to talk about two kinds of machine learning that we're going to talk, known as supervised machine learning, and second being unsupervised machine learning. So I will give you an example of both. So let me start with let me start with supervised machine learning, and then we'll go into okay, should I start with supervised or unsupervised? I'm confused. Okay, let's start with unsupervised machine learning. Or should I start with supervised? Okay, let's start with supervised. Who cares? Yeah. So supervised machine learning comes from the fact that the terms the training data is properly labeled. So let me tell you what that means. So supervised machine learning would be something like, imagine that you are training a baby to distinguish between the images of a cat and a dog. So every time you tell, so let's say you're telling the baby to learn about the difference between the cat and dog. So I guess it's imperative for me to right now tell you the difference between actually programming, traditional programming versus machine learning. See, what you have to understand is that the machine learning in traditional programming, you teach machines to do certain tasks based on instructions. So if it is like, let me open this thing. Give me a sec. Right. So your traditional machine. So what happens is that programming is the ability to teach machines to do tasks based on instruction. And for example, these instructions could be basically these instructions are your code. Okay, so you usually write in a high level language such as Java, C++, or Python. Okay, but your machine learning is actually the ability. So I'll just remove this thing. So machine learning is the ability to teach machines. Hang on, learning is the ability to teach machines to do tasks based on not on instructions but on examples. So instead of writing code, like instead of writing proper code set on stone, that these are things, if there is an ear and if there is a long ear, if there's a long snout, probably it's a dog. Instead of doing that thing, you give machines a bunch of images, a bunch of data to train on, and then the machine will automatically find patterns between all the training data and will come up with a general solution to identify which image is that of a dog and which image is that of a cat. Okay, so it is the machine's job to find patterns. So machine learning is the entire machine learning is basically the ability of machines to find patterns from the data. Okay, and based on those patterns, the machine will infer certain things. Now, if I give, so let's say, if so, what happens in supervised machine learning is that, let's say I'm giving an image of a cat and a dog, and with each image, so I let's say that there are 1,000 images of a cat and cats and dogs, so 500 each. So when I, let's say I show the image of a cat to the machine and I tell them it's a cat, and similarly I show 500 images of a cat in different angles, different cats and everything. So hopefully the machine should have learned certain traits. For example, the cat, let's say cats have pointy ears, have cat-like eyes, are small in size, let's say that, and have whiskers, long whiskers. And then I will, and with each training data, like with each image, I will tell that it is actually a cat. So for example, let's say there is an image over here. So I'll talk one image over here. So this could be a cat. Okay. So something like this thing. So I will label them that it is a cat. Then I will give 500 images of different images over here. Similarly, I will give almost 500 images of, let's say, a dog. So I'm not really sure how to draw a dog over here. Something like this thing. I don't know what I'm doing. So something like this thing, a dog. Okay. And I will tell the machines that these images are that of a dog. So I'm not extremely good at drawing, so forgive me that. Forgive me for my poor drawing skills. However, when you offer 500 images of a cat and 500 images of a dog, by the end, the machine should have learned that because of certain features such as pointy ears, okay, or perhaps a long snout, it would be either a cat or a dog. Now you're not writing any code over there to giving instructions. You're writing the code to tell the machines on how to learn it. Okay. And this would be an example of supervised machine learning, because in your training data, when you were training the machine to learn, you were telling them that with each image you are also labeling the image as either a cat or a dog. Okay, so these labels are which tells that it would be supervised machine learning or not. In other words, you are kind of supervising the machine while it is getting trained. Okay, so for example, similarly, I'll give you one example over here. Let's take the example of housing price prediction. Okay, let's say you work in a company and the company went out and collected some data. So the data could be like this thing. It could be, let's say, X and Y. And X-axis has a size of the house in square feet, and the Y-axis contains the price of the house in $1,000. Okay, so basically what I'm trying to say is that house of size, let's say 500, will be around 120, sorry, 400, let's say this part will be around $100,000, 100K. Similarly, house of 500 would be around 120K, so on and so forth. So basically, someone in your company went out and conducted a survey, and this is the data that they found. Nothing fancy, and whatever the data they found, they plotted in a 2D graph over here, such as this thing. And when they plotted, they could find a trend that as the size of the house increases, the price also increases. Okay, and I know like the price of a house depends on several factors, such as, let's say, the size over here. The other factors could be the number of bedrooms, number of bathrooms, the neighborhood, number of balconies, so on and so forth. Yeah. Um, and other factors like, is it a detached house, is it a condo, like is it an apartment or a flat, or what, or is it a townhouse, such things like that. Now we are taking only one factor over here. Now the price, since the price is depending on the size, I could say that this is the predictor variable. In other words, this is used to predict the target. In other words, I will say that this is the size would be, the x-axis would be the predictor variable, and the price over here would be the target variable. Okay, so I guess you could say that you are trying to create such a thing, where the predictor is a mapping to the target. Okay, kind of thing. Yeah. So over here, each data point contains a label. So you may ask me what is the label. So this data point may has the coordinates 400, 100. This will have the coordinates, let's say 500, 120,000, so on and so forth. So as you can see, these are the labels present over here. In other words, I'm telling the machine, in this case the machine learning model, that if there is a house of, let's say, around 500 square feet, its value should be around $120,000. Okay. And now my idea, so I will ask you to, can you predict, given this data, could you predict what would be the price of the house whose size is around 750 square feet? So here you want to predict the thing. So to do that, you will try to create a machine learning model which will kind of fit through this data. So for example, let me change the color. So there are multiple models that are possible. So one model could be this. Okay. The other one could be, let's say, let me change the color once again, could be this. Let's say this thing. I guess most of you will agree with me that the blue model is more representative of our data. Why? Because as X is increasing, the Y is also increasing. While on the other hand, the yellow model is it's quite the opposite. As the size of the house increases, it tells the price will decrease, which is kind of bollocks. Yeah. So if I were to ask you which one is better, model number 1 or model number 2, like blue model or yellow model, I guess it's reasonable to say blue model is a better fit to our data. Okay. This is the basic idea behind linear regression. This is known as linear regression. So let's say this is the first model that I made. So based on this model, I saw that if I were to guess or predict, the price of a house of size 750 square feet would be around $210,000. Okay, fair enough. But if I were to ask you, is this the best that you can do, or is this the best fit to a model? I would say no, because there might be a better fit. For example, something like this. Yeah. And I would assume that most of you will agree with me, because this curved line, or in other words, polynomial line, is actually a better fit to our data. As you can see, it is fitting through this thing. It is, for example, this violet one, this straight linear model is actually missing some of the data points. but this one is actually covering most of them. I know, like, it is missing this data point, it is missing this one. I know that, I'm aware of that, and that is absolutely fine. That is the general idea. You have to capture the general trend of the data. That is the only thing. You don't have to like, you don't have to create a line which will be something like a line such as this. For example, let me change the color once again. If you try to form a line whose which is something like this thing, this line, although it is capturing all the data points, this is not by looking at this data set, this model is not reliable. Why? Because according to this data, as x increases, y is kind of unpredictable. Like in this case, it is kind of decreasing, which is not the case. So I guess it is safe to say that this model over here is the best fit to our particular use case. Okay. So this is an example of the supervised machine learning. So let me repeat what was supervised about this. Well, each data point was labeled over here. As you can see, each data point had a label associated with it. Like 400 was getting mapped to 100, 500 was getting mapped to 120, so on and so forth. Yeah. So because of the labeling part, this is known as supervised machine learning. So what would be the unsupervised machine learning? Well, quite the opposite. Where data is not labeled, it will be unsupervised machine learning. So I will explain this also, and then I will give you a short break. Okay. So like, I'll give you a break in about 5 minutes. So hang on, so bear with me. Let's see what unsupervised machine learning is. So back in 2020, 2020 Jan, I went to Mysore campus, Infosys Mysore campus, for my internship. And there I met, in my intern class, there were about 192 interns, other interns. And these people were from all parts of India, north, south, east, west. Like people were there from Punjab, people were there from Kerala, people were there from Tamil Nadu, people were there from Assam, people were there from Gujarat, Odisha, north, south, east, west, from everywhere. And I noticed that people from similar background, similar college tend to stick together. Therefore, they are more likely to stay friends or become friends. Yeah. So I imagine, like, let's have a thought experiment over here. Let's strip off all their differences. Let's strip off their language difference, their cuisine difference, cultural difference, cuisine difference, every difference, like all kinds of difference. And if I were to give them only two parameters, that is interest in football and interest in philosophical discussion, I have to find out which people tend to stick together, therefore more likely to become friends. So the question is, the problem at hand is, I have to find out, based on these two parameters, which people are more likely to become friends. Okay, so obviously I cannot take 192 people on the screen. It will become very messy. So I took 15 random people over here, and these small tiny dots represent each of them. Okay, so I'm not really sure, like, what is this person? Is this person a guy or a girl, or is this person from northern part of India, southern part of India? I have no idea. Now, since I have no idea about the data set, in other words, the data is not labeled over here. The data, like this data is almost identical, identical to this data. Yeah, there's no difference. Because of that, I would say that this data is unlabeled. So this is a thought experiment. And when I asked these 15 people to go and place yourself accordingly, depending on your interest in both of them, they spread out like this. So for example, this person has a high interest in football, so could be watching football, playing football, and also has high interest in engaging in, or at least listening to, philosophical discussions such as, let's say, John Pearson, Carl Jung, or could be religious discussion as well. Could be anything. We don't really know. Okay, could be philosophical, psychological discussions that engages your prefrontal cortex. Similarly, so obviously, so this person when came here, this person found out that there are two other people who shares his or her interest. So in other words, I would say that based on these two parameters, this person will stick with these two folks, And therefore these three folks will kind of form of a cluster, or in other words kind of will are more likely to stay together or become friends because they are sticking together because of the shared interest. And we become friends with people with whom we are compatible, aka, or in other words we are, we share their interest with us, ours. Similarly, this person over here went over here because this person enjoys philosophical discussion but not so much in football. So, and when this person came over here, this person found out that there are three other folks who share his or her interest. Therefore these people are more likely to become friends. Okay. So as you can see, this based on these two parameters, there are four clusters being formed. Now because these are the four clusters are formed, this is an example of clustering algorithm, which is an unsupervised machine learning algorithm. Okay, pretty simple. So what was unsupervised about them? Well, the data were not labeled. That is what unsupervised. So I could not supervise them. That is why I have to define some parameters so that I could find some patterns from the data. As you can see, because of my parameters, interest in football, interest in philosophical discussion, these patterns emerged. Okay, if I were to change the parameters, the patterns would also change. So this is an example of classic example or textbook example of clustering algorithm or unsupervised algorithm. So these are the two kinds of machine learning that we are going to focus on in the 2-day session. So I'm going to give you a break right now. So how long do you need the break for? Anyone? Any recommendations? Or should I be the one to decide? I guess it's almost 12 now. I guess you will require some time to have your lunch or something. So shall I give you a break till 12:30? Yes, no? Or do you need more? Or do you need less? Okay, perfect. So I guess we'll take a break till 12:30, and then from 12:30 we will continue with the coding part. Okay, and the coding part will look something like this. Let me tell you over here. So we'll start with linear regression. So it will look something like this thing. So we will continue with that. I will actually type the code. Okay, and I will walk you through the code myself. Okay, all right. So I guess we're good. Please go and take a break for half an hour, and we'll be back by 12:30. So with that being said, cheers. So before we actually leave, any questions, any concerns, anything that you may want to ask me? Come on, folks. I'm just the moderator over here. I'm just the guide over here. You have the right to ask me. Nothing? Okay, all right. Good enough. So we'll take a break now for half an hour, and then we'll come back at 12:30 and we'll continue.